Good evening, all. Let me introduce to myself. My name is Priyanka Tomar. I am a PhD scholar. I am currently pursuing PhD from IGDTU Delhi, that is Indira Gandhi Delhi Technical University for Women, and it's located in Kashmiri Gate. I have passed my MTech from Banasli Vidyapeeth in 2017, and I have also qualified NTA UGC NET in 2021. So, I will be taking one topic today, that is binary search tree, which comes under the data structure subject. So, let me share my screen first of all. So, here it is. That is what is binary search tree. So binary search tree is basically a node-based binary data structure, which has the following properties. It means, what does it mean? That it is a data structure that contains data, which stores data in the form of a binary tree, in the form of a tree. So it contains three properties. That is the root node, like a tree, it always have a root node, and it always have its sub childrens, like a parent node and its left child and its right child. So that is not at all compulsory that it should have two childrens. That is not at all compulsory. But like I said, that it is the property of a binary tree, that it must have a node, root node, which will contain its subchilds. So here it is having the properties as follows, like the following subtree, the left subtree, which is having the nodes, it should be less than the root node. The root node will be the greater than the left nodes. Okay, and the right subtree, the root node should be the right subtrees nodes should be the greater than the root node, and the left and the right subtree each must also be a binary search tree. What does it mean? That the binary search tree properties will always follows in the left subtree and in the right subtree. Like in this example, we can see that the 8 is the root node here, and 3 this left hand side is the left subtree, and this right hand side is the right subtree. Okay, so the all nodes which are present in the left hand side of the 8, they all are less than 8. So the left subtree, it is containing elements which is less than 8. So we can say that the left subtree is less than the root node. And again, here in the right hand side of 8, we can see that there are three elements, uh, namely 10, 14, and 13. These three elements are greater than 8. And let me come to the last property. It is the last property, that is the left and right subtree each must also be a binary search tree. What does it mean? So let me explain you. In this example, we can say that 3 is the root node. In the left subtree, 3 is the root node, and 1 is the left child of 3, and 6 is the right child of 3. So it is also following the binary search tree property, because 1 is the left child of 3, which is less than 3, and 6 is the right child of 3, which is greater than 3. So again, in this small in this subtree also, 6 4 7 wale tree mein, 4 is the left child of 6 and 7 is the right child of 6. So we can say that 4 is less than 6, 7 is greater than 6. So it is also following the property of binary search tree, that is left and right subtree each must also be a binary search tree. Okay, so we can say that a binary search tree is a binary tree data structure which stores data in the form of the nodes, and it always follows the three properties, which are like left subtree, left nodes of the binary search tree should be smaller than the root node, and the right subtree nodes should be greater than the root node. So I hope that this explanation of the binary search tree is clear to you. And so I have taken one example here. I have taken one example here. Construct a binary search tree. BST is the short form for the binary search tree for the following sequence of numbers that are 50, 70, 60, 20, 90, 10, 40, and 100. Okay, so they all are the elements which will be stored in the binary search tree. So we have to follow the three properties which we have studied just now. So I will try to construct one binary search tree in front of you. Okay, so for constructing a binary search tree, we have to keep three things in our mind. First of all, first of all, take first element as the root node. Okay, this is the first point. This is the first and the most important point which we have to remember while constructing a binary search tree. Like these are the elements, and इसमें the first element we have to take it as the root node. Okay, and then second, after taking the first element as the root node, so here I am taking 50 as a root node. Okay, here 50 as a root node. Second, follow the BST properties. Follow the BST properties for constructing the binary search tree. Okay, so what we have to do now? Second element is your 70, right? Second element is your 70. We have to examine what it is. Like it is less than 50, less than root node, or is it greater than the root node? So it is greater than the root node, right? So what we will do, we will take 70 as the right child of the root node, which is 50, जो कि हमारा 50 है. Okay, we will take 70 as the right child of the root node. Why so? Because 70 is greater than the root node. Okay, so here I am copying it and making it as the sorry, wait a minute. Why it is not this? Okay, 70 now. 70. Okay, 70 is the right child of 50. Okay, now comes to the third element, which is 60. Okay, it is also greater than root node. We will always compare with the root node. Remember this point. Okay, we will always uh, compare all the nodes, all the elements with the root node. Okay, so 60 is the third element and 60 is greater than root node. Then we will put this 60 in the right side of the 50, but in the left side of 70. Why so? Because 70 se chota hai 60, so we will make 60 as the left child of 70. Okay, so I'm taking, here it is, and here I will write 60. Okay, and then I will make 60 as the left child of 70. Cool, good to go. Yes, 20, next element. 20 is the fourth element. We have to place in the binary search tree. Now compare it with the root node. We have to check whether it is smaller or greater than root node or not. Okay, so it is less than 50. So what I will do, I'll make 20 as the left child of 50. Okay, okay, fine. Now next number is your 90. 90, which is greater than 50. With next we have to write which is greater than 50, which is greater than the root node. What I will do, I will place 90 in the right side of the 50, in the right side of the root node. Okay, so it will come in this side, right? It will come in the this side, right hand side. It will be the right, it will be the node of the right subtree. Okay, but it will come, it will become the right subchild of 70. Why so? Because it is also greater than 70, right? So I will place 90 here, and it will be the right subchild of 70. Okay, good. 10, 10 is the next element I have to place. Now I have to check, I have to compare it with the root node. I have to compare it with the root node, and it is smaller than the 50 now. It is less than 50. Okay, I will place in the left subtree, in the left side of the binary search tree. Okay, and it is also less than 20. So it will become the left child of 20. It will come, it will come in the left side of the 20 node. Okay, 10. Okay, 20 का लेफ्ट चाइल्ड कौन सा है? 10 है। 10 इसके रूट नोड है। 10 सॉरी 20 इसका रूट नोड है। 10 इसका लेफ्ट चाइल्ड है। ओके, नेक्स्ट 40, अगेन कंपेयर विद द रूट नोड। 50 से छोटा है, लेफ्ट साइड आएगा, लेफ्ट चाइल्ड बनेगा। 20 से बड़ा है या छोटा है? बड़ा है, सो इट विल कम इन द राइट साइड ऑफ 20। 40, it is now left child of 50, but it is right child of 20. Getting my point? Okay. Now we only left with the last element, that is the 100 one. Okay, that is the 100. Okay, 100 compare with the रूट नोड, बड़ा है राइट साइड आएगा. 70 अगेन बड़ा है राइट साइड आएगा. अगेन 90 से कंपेयर किया, बड़ा है राइट साइड आएगा. सो 100. मेक इट एज इट्स राइट चाइल्ड. ठीक है, ये थोड़ा कंजस्टेड सा हो रहा है, बट प्लीज ट्राई टू अंडरस्टैंड इट. 100 जो है वो 90 का राइट चाइल्ड हो जाएगा. सो हेयर it is the binary search tree for this particular sequence of numbers. I hope that this concept of binary search tree is clear to you, and thank you so much. I hope to see you again. Thank you so much.